Hello everyone. If you look at a basic, web application architecture from a very high level, uh, you can see that there is a person over here who is sitting and has just opened up a browser, and say he needs to access a web application. It could be the application, say you want to transfer some amount to someone else. So you open up the banking web application. So how do you do that? You go to you go and use any internet browser, right? So you just need a machine. It could be a desktop like this, or it could be a laptop. It could be your mobile phone. It could be your iPad, your iPhone, or an Android phone, or any device that is connected to the internet and has got a browser installed. So which are the browsers that you could use? Internet Explorer, or Chrome, or Mozilla Firefox, Opera, Safari, whichever is the one that you prefer. While Chrome is the one that is the most popular in the market. So basically, you need a machine that is connected to the internet and the software that is installed on the machine, which is called the browser. In the earlier days, the browser software was something that you had to install separately. Today, it comes along with it. It's installed along with the operating system, so you don't have to install it separately. So Internet Explorer is available along with when you install Windows. But if you need any of the other browsers like Chrome or Firefox, then you can have to install it separately. But once you have that, then you have access to the internet, and whichever URL that you open, it may lead you to say a web application. So if you open up say Gmail to check your emails on the Google Mail. So when you go to gmail.com, it's basically a web application. So you have so many more examples of web, say your banking kind of applications where you open up your account information on the banking site. So when you visit their website or web application, so these are all synonymous. So what we are talking about is the web applications or websites that we look at. So how do we use the Java Enterprise Edition to develop a web application like that? So for that, we have to first understand at a very high level what is the architecture of a web application. So the first piece is the client piece. This is what we call as a client, the person who is interacting with the application from the internet. So this is the client. This is also called the presentation tier. So the presentation tier, because it has the logic that is required, or the UI piece of that, so the user interface. So it has the piece that is actually interacting with the end user of the application. From there, when the person sends a request, say you are trying to log into a banking web application, you put in your login ID and your password and maybe a captcha, and then you say login. What you are sending is a request through the internet. Now the internet, or any means of communication, also has a protocol associated with it. So say when we go and visit somebody, that is a protocol that we use on a particular occasion. So if you are in a ceremony and you are receiving your guests, there's a protocol. You say hi, hello, how are you doing? Thanks for coming, and then you invite them inside. So that's basically a protocol. So in the same way, even machines in the internet world, they follow some kind of a protocol, and that protocol is called the Hypertext Transfer Protocol, or HTTP. That is a protocol that is used in the internet. Okay, so from your client machine, if you need to connect to a server which hosts your web applications, you need to use a protocol called HTTP. Now, HTTP is the Hypertext Transfer Protocol. If you are basically from computer science background, then I think you'll be aware of HTTP, and then it runs on top of the TCP/IP stack. Uh, we'll understand those a bit later, but for now, if you know that if you understand that HTTP is the protocol that is used by the internet. Now, even if you log in, when you go to the browser, if you have to type in the URL of the application that you want to access, the particular address that you put, you say any application has its address. So if you have to go to Gmail, you say http://gmail.com. You may not have to type http. You just say the gmail.com, and then by default it takes it as http. So HTTP is the default protocol that is used by the internet. So when you are trying to access a web application from the browser, the default protocol is HTTP. And then what happens is that Gmail redirects you to redirects the user and then establish a secure connection using HTTPS protocol. Okay, so it could be HTTP or HTTPS. HTTPS is the more secure connection, whereas HTTP is the unsecure connection. Now, from the client or from your client, when you're trying to access the web application, the request is directed to a server called the web server or the HTTP server. So when you hit gmail.com on your browser, and what it does is it sends an HTTP request to the server that is available on gmail.com. Gmail.com is basically an English-like name, right? But then internally it is converted into an IP address. So there is a separate server that is available that is called the domain naming server, DNS. That is available, the separate servers that are available throughout the world. So those servers, the DNS servers, they ensure that your whatever address that you have typed gets translated into the correct IP address. Now, once say gmail.com it converts that into the appropriate IP address, and the request is directed to the server with that IP address. Now, once it reaches the server with that IP address, which is also called the web server, it redirects the request internally to any particular application server for further processing. For example, if you are trying to access Facebook or Gmail, there's a lot of data that is associated with a particular account. You may have a lot of videos, or you may have uploaded your photos or images. Now, all these content that you see on your web application, that may reside in a database, or it may also reside on a file server. So usually your images and videos reside on your file server, whereas all your text kind of data, they go and sit in a database. Now, based on how your web application is designed, it may reside on different servers. So it could be a file server, or it could be an application server, it could be a database, or wherever it resides. So basically, a web server is a server that hosts the logic that is required for interacting with the client, whereas your application server is the server that hosts the application that has your business logic, and it interacts with the web server, and it also interacts with the database in the backend. It could interact with the database. It could interact. Your application server could finally interact with the database to say pick the appropriate files or from the database, or it could also interact with file server to retrieve the files that are stored on the file server. It could also interact with other systems within the organization. So it could also be connected to the intranet. So that is a whole flow of your web application and a very high level overview of the web application architecture. So to reiterate or to rephrase, say you are trying to access Gmail, you type in gmail.com. By default it takes HTTP, and that HTTP request is sent to the web server, or the DNS server that translates your gmail.com address into the IP address, The the host with the appropriate IP address is your basically your web server that accepts the HTTP request. So this HTTP request is accepted by the HTTP server or your web server, and then that to complete that request, say you want to send an email to someone else, or you want to retrieve all the emails in your inbox. To complete that, it needs to interact with the database. But your web server will not directly talk to your database. It will talk through the application server. So the application server has a logic that is required to connect to the database, retrieve all the information from the database, and fetch that information, and it fetches it and it sends it back to the web server. The web server, again, it is responsible for the presentation type logic. So it puts in all that data in a format that your client can understand. So it could basically be something like an HTML page. So it writes that HTML page and it sends it back as an HTTP response. So you get an HTTP request, the web server accepts the HTTP request, it processes the HTTP request through the application server that may interact with the database, and then finally it fetches the data, it sends it back to the web server. The web server puts that data in a format that is that is readable by the user. So it could be an HTML page. So it sends that HTML page back as an HTTP response to the client, and the client can finally be able to see all his emails on his inbox. So that's the whole flow. The first tier is called the presentation tier. While the one that we see over here, this is the presentation. And the presentation tier, where the web server, it hosts the presentation tier logic. Okay, and your application server, it hosts the business logic that is required. Okay, so that's the whole flow. So those are the three different layers that we are going to look at. Okay, so the presentation tier, while the presentation tier itself is the client itself, the logic for the presentation tier is hosted on the web server. The application server hosts the business logic, and then you have your database tier as well, which has the data. Looking at the technologies within Enterprise Java that you'll be using for each of these tiers, so whether it is the presentation tier or your middleware or your database. So the presentation tier is basically your web browser, which you have on any of your devices, on your mobile devices or your laptops or desktops. So anything that has a web browser installed and is able to talk to the internet, that is basically your client machine. But then that sends an HTTP request to your web server. Your web server has, what is the technology that you'll be using for writing your presentation logic is it's Servlets or JSP is what you'll be using. So within Enterprise Java, you have these two technologies that you can use to write your presentation tier logic. So what is your presentation tier responsible for? It is responsible for accepting the HTTP request, okay, and sending that HTTP request to your business logic tier, which is your EJB container over here. Okay, the business logic tier, it interacts with the database, it processes all the information and sends back that data to your web container, which is the servlets and JSP pages, and then your web container, it takes in all that data and it sends it back to the client in a format which is presentable. So that's the presentation logic. So your web container, which has your servlet and JSP kind of applications, it is responsible for the presentation logic, whereas your EJB container, which is which has your EJBs, they are basically responsible for interacting with the database and processing all that data So they're responsible for all the applying all the business rules on any business logic or any computation or anything that happens. It happens in the UJB layer or the business logic layer. Okay. So once that is processed, it sends back that data, the processed data, and the web server or the web container over here, it is only responsible for presenting that data. Okay, so that's the whole flow. The database is hosted usually on a different server called the database server. Okay, uh, so what we are seeing over here is one form of the architecture. The client machine, it resides wherever the person is sitting and he's trying to access the application. Okay, whereas the rest of it is internal to the organization. So uh, your part is to design the whole of the presentation logic and the business logic. Usually the presentation logic, it resides on something called the web server, okay, or the web container. And the EJB container over here, it also it requires an application server for hosting it. Okay, so this is also part of the application server. Now, in some cases, you may have your Servlets and JSP, which is your presentation tier logic, also hosted on the application server itself. It's also called the Java Enterprise Edition server, so the Java EE server. Now, the database is hosted on a different server. So, say you have Oracle database or you may have SQL Server database. Usually, these database instances would be running on a different box, different server altogether, to which it may not just be this application. This database could be connected to many such applications and many such servers within the organization. So, this is just one server which is connected to this database, but the same database could be connected to many other application servers within your organization.
Thank you.
So, basically, you have your presentation tier logic. Okay, apart from the client machine, you have the presentation tier logic, which is written using Servlets and JSP. You have your business logic, which is written using EJBs. And you have your database tier, which hosts your data. So it could be Oracle or SQL Server database, which is usually hosted on a different box. Now, keeping these in a separate box, now keeping your Servlet and JSP, your Servlets, your JSP, one option is like having your web container as well as your EJB container on the same box, on the same server. That is possible. That is one architecture. The other one would be to split your Servlets and JSP, move your Servlets and JSP into another server called the web server, and your EJBs onto another server, which is more of your application server. Okay, so that is the second option in which you can design the architecture of your application. But then usually when you're working in an organization, you will not have much of a say. As a Java developer, you will not have much of a say as to where you would be hosting it. It would be usually be looked at by a person called the system architect. He would look at all the other applications as well. It would not just be Java. You will have .NET applications. You may have applications that are using pure JavaScript applications, the main stack applications, or the big data kind of applications, MongoDB, or any of the your organization may be having applications written in almost any other language as well. So to host all these heterogeneous kind of applications, what is the total system architecture that one has to come up with is the job of a system architect. But as a Java developer, what you would have to do is understand the architecture that your organization is using. So is it being hosted on a different web server? Usually the web server and the application server are going to be different. They're going to be two different servers. So you'll have to understand the whole architecture and then write your code accordingly. But from a logical standpoint, yeah, these are the different types that you will have. Okay. Now, looking at now, the first thing that we'll do is, in Enterprise Java, we'll start looking at servlets, and then we'll look at JSP. So servlets itself may take 2 or 3 sessions, and then we'll start looking at Java server pages. Uh, so to understand, both servlets and JSP, first let's see what JSP is. JSP is basically used for web pages or building dynamic content. Okay, so job that is done by the servlet and the JSP technology, they're both the same. They both the same in terms of they accept an HTTP request. Okay, an HTTP request, they accept an HTTP request, they process, they send that request to the EJB container for processing. That data is processed, and then they take back the processed data and put it in a particular presentation format and send it back, send the HTTP response back to the web browser. So this is what both servlets and JSP kind of pages do. But the only difference between the servlet and JSP at a very high level is that the servlets are more into the logic. They have the logic into as to how the data has to be what is the data that is coming in from your web browser or from your client machine. So if somebody is requesting for access to gmail.com, and it's your application, assume that the application that you have for Gmail is your application, and you are using servlets for that, then uh, while you accept that request, you'll be looking at what is the request for. The request is for displaying all the mails that I have in my mailbox. But the servlet itself will not have all the data. So the servlet, what it will do is it will hand over that particular request to a particular bean, which will interact with the database. It will fetch all the emails, and it will get back all the emails. And then what the servlet will do is it will want to present it in a specific format. Now, for presenting it in a specific format, JSP is the preferred technology. So the servlet gets back all the data. So what the servlet does is it accepts the request, it sends that request to your business logic tier. It gets back the data, and then it processes to put it in a format which is presentable. It hands over all that data to the JSP page, and then that JSP page is returned to the web browser, which is something. So the web browser knows how to render that JSP page and how to show you all the emails that you have requested for. So while servlets are responsible more for the processing logic, processing the HTTP request, and then getting all the data from the backend, the JSP is more responsible for the presentation. So even though servlets and JSP internally they are the same, there is only a very slight difference. So you'll know the difference when we look at it, when we look at the code and we look at it in more depth. So JSP, it's used for web pages with dynamic content. Of course, we can directly use HTML itself, right? We can directly use HTML itself, but we use the JSP pages to add, more dynamic content into that. So by adding JSP, what you have done is, like, after you get the request, you can create a page. As part of the response, you can create a page which is more interactive, which has certain buttons which can interact with the user. So the user can do certain things on the page. So he can click on, say, the mail, and then it opens up the complete email, and then he can reply to a person. So that it is very interactive in nature. So that is what it means. So it is used for web pages with dynamic content, where the content is, if you get a new email, then it shows up the new email in your mailbox, right? So the content is dynamic, and it processes the HTTP requests, okay, and it accepts the HTML tags, the special JSP tags, scriptlets. You'll understand more of this when we look at JSP. For now, what you have to understand is that the JSP is Java server pages technology, which is used for building the pages on the server. So Java server pages means you're building the web pages on the server itself. So JSP is the technology for building your web pages on the server, and of course those web pages have dynamic content. Today, if I say that it has only static content, it may not make sense because we have come too far from having just static content on websites in the early 1990s. Okay, so basically it separates the static content from the presentation logic, and it can be created by the designer using HTML tools. So your JSP pages are more or less HTML with some dynamic content in that. Okay, so it's very much like HTML. It looks like more like markup language like HTML itself. It is HTML with some dynamic content embedded into that. Whereas servlets is used for web pages, again it's the same. The purpose is the same. The main purpose is to process the HTTP request. Okay, so the servlet accepts the HTTP request and then it processes the HTTP request. Of course, it is written in Java and it uses print statements to render HTML. If you have to directly send back HTTP responses from a servlet, then you have to use print statements, which then finally render HTML. I'll show you with the example. Okay, it is loaded into memory once. This also we will see in the next slides, in the upcoming slides. So basically, JSP and servlets, these are two different technologies that we will be using on the presentation tier. Okay. So let's start looking at servlets. Okay, so focusing on servlet, okay, it's basically a technology that is used to create a web application, and where it is hosted on the web server or the application server. So that's why I just put server over here. It could be a web server or an application server. The terminology that you use for the server may differ based on what else is installed on the server. So if it is just the presentation tier logic that resides on that, then you can call it a web server. Whereas if it also hosts logic that that is more of business logic and it interacts with the database, then it's more of an application server and that is from more of a functionality standpoint. So basically, you have a server. Okay, so to keep it simple, you have a server, you have a client. The client, when it has to access a web page through the internet, it sends a request, which is an HTTP request. It sends an HTTP request, and before it responds, before the server responds, it considers the business logic tier, it fetches from the database, and then that data it puts it in a format that is readable by your client. Now, what is the format that is readable by your client or by your browser? It could be an HTML page. So if you have an HTML page which ends with .html, that is easily read or rendered by your browser. In the same way, your browser can also read .jsp pages as well. But first, let's look at servlet technology. So you get an HTTP request, and your servlet has a logic that is required for sending back an HTTP response, which is an HTML page. Okay, so the servlet is also an API. Okay, so how do you write those servlets? For that, you need an API, right? That is, for example, for writing your collections or for writing a JDBC, you use the API that is already available within your Java Standard Edition library. So in the same way, your Java Enterprise Edition, if you see, Enterprise Java also has the API that is required to write a servlet. Okay, so basically, a servlet, you have to write a servlet program that will accept an HTTP request and send back an appropriate HTTP response. Okay, so the servlet is an API that provides many interfaces and classes, and it also has documentation as well, very similar to the Java SE library that we already saw. For Java libraries, we have Enterprise Java libraries for writing a servlet. Now, servlet is also an interface that must be implemented for creating any servlet. Okay, so that will be clear when we look at the program. So it's basically also the name of an interface that you should override. Okay, that you should extend. or implement. So how does a servlet work? Okay, so this introduces you to a very important question that you usually face in interviews, that is the life cycle of a servlet. Okay, so what is the life cycle of a servlet? So you've written a servlet class. Now, how does that get executed? Is what is explained in the slide. So basically, you have the client which resides, somewhere else on the internet, right? So you have an HTTP request that comes in from the client to say some other server that may be hosted on inside your organization. Okay, that is just you know after the firewall, you have an HTTP server, a web server, or any particular server which sends the specific HTTP requests to the web container that hosts your servlet. Your servlet, what it does is it creates a request and response objects. Okay, it creates a request and response objects and it feeds it to the servlet. So your web container, which you need for hosting your servlet. Okay, all the enterprise Java technologies like servlets or JSP or EJB, all of these, they need either the web server or the application server to host, to be able to run that. Because your libraries that we are talking about, your core Java libraries were available within your Eclipse environment after you install Java runtime environment or JDK. But your enterprise Java libraries will be available only if you install an application server or at least a web container. Okay, so for your enterprise Java libraries are available within something called the your application server, or for your JSP and servlet, it is enough if you install a web container. So an example of a web container is, say, Tomcat. So Tomcat is an example of a web container on top of which you can host your servlet and JSP pages. So that web container is responsible for accepting the request. What it does is accepts the request and it creates the request and response objects that can be used by your servlet. Okay, just understand the flow here, because we are going to look into this by writing a program, and then it will be more clear. Then the web container, which has your Java Enterprise Edition libraries, it creates your request and response objects and it feeds it to your servlet. The servlet reads the request. Okay, the servlet reads the request and it creates the response. It writes the response to the response object and it sends the response back. And the web container knows to which client it has to send back the response to. So the web container, or basically a web server, it knows to which client it needs to send back the response to. So basically you have an HTTP request. With that HTTP request, the web container, like Tomcat, it creates your request and response objects. And once the request and response objects are created, it is fed into the servlet. The servlet reads the request and writes the response and sends back the response to the web container, to Tomcat, say, and Tomcat knows, to which client it needs to send back the response to. So that is the whole flow. Now, looking at specifically into the servlet, once you write a servlet class, okay, you may have just one servlet class that you have written, and you may have just one servlet object that is accepting the request and sending back the response, right? So say you have, it's not just one client that is sending in the request. You may have parallelly maybe 1,000, 2,000, 5,000, 50,000, or if it is Facebook, maybe 1,000,000 clients that are connected to the same application. So everybody is trying to open gmail.com, or everybody is trying to open Facebook or Wikipedia or Google. Look at these kind of applications that have concurrently so many different users. So how can one object, which is the servlet, cater to all the requests? Okay, all the requests that are coming from all the different clients that are connected concurrently. So to cater to all the requests, there is still, though there is only one object over there, there are multiple threads of the same object. Okay, so there are multiple threads of this particular object, that is a servlet object, that are created, and you have a pool of threads that are created inside your web container. So say your servlets are hosted on inside Tomcat, you have a pool of threads that are hosted. So you can define within your web container as to how many threads do you want to create. Now, how many threads can you create? You can't just say, okay, I want to create 10 threads, 20 threads, 100 threads, 1,000 threads. Of course, it depends on the underlying platform on which the web container is hosted. Can the hardware take in so much? Can it really process so many threads? Okay, so it depends on the configuration, the hardware configuration also. So based on a lot of such factors, the architect will take a decision on how many threads of the servlets should he allow creating. So if you have 20 threads, you can parallelly process 20 requests that are coming in from the client. So if you have 40 clients, so you have if you say have 100 clients, but you have only 20 threads, then all the other requests will be in the queue. Okay, but the threads, but these servlets, and the threads, these work very fast. You know why you will not feel the differences? uh, for every request, okay, for every request, the thread is just responsible for getting in the request and then sending the response, right? But the business logic, when it is processing the business logic, when it's trying to access the database, all this logic is not executed by the thread. So once it hands it over to some other business logic class, or when the business logic tier is trying to access the database, this thread is free, right? So this thread can be accessed, and it can cater to some other requests. So effectively, you can parallelly process more than 20 requests, even if you have 20 threads, right? So uh, so, uh, this is more to do with performance tuning, and more to do with system architecture. And once you are a Java architect, you have to start thinking in these lines. Uh, so how, what is the kind of server that you are using, whether to keep your servlets and your JSPs in the same web container, and your business logic, where is the business logic residing, where is your database server hosted, what is the hardware configuration that is required, how would you benchmark your applications, what is the resources, what is the RAM, what is the memory that needs to be allocated, what is the CPU that you need, what is the hardware, the server configuration, should you allow this to be hosted on the cloud or not. So all these, you'll be able to answer all these questions as you get more experience, and you write a few applications and start thinking in terms of systems. So that is more of systems thinking, and system science, or there's another field that deals with it. It's called operations research. So uh, that's a totally different field. But as a Java developer, you will have to understand a little bit of the flow, so that while writing the program, how do you make sure that you don't lock any particular request just for the servlet. Okay. So
Pawan, what is the difference between web server and web container?
yeah, see, over here in this diagram, the web server is the server that is directly taking in the request from the client. Now, your organization may not just host your Java applications. It may also have .NET applications. It may have some other applications that are also accessible from outside your organization. So your web server, this part is the server that is rerouting the applications, rerouting based on which application the client is trying to access. It will reroute it to either this web container or to some other web server or application server based on what the request is. Okay, so this web server is acting more like a more like a load balancing feature. It's more like a load balancing feature here, and it acts as more like for routing the particular request to the Java application or the .NET application, which could be hosted somewhere else. So if it is a Java application, if it is the servlet application that you have written that this client is trying to access, then this web server will route it to the web container. The web container is now the something like Tomcat, which can only host JSP and Servlet. It cannot host EJBs. Okay, so web container is a is a subset of the application server. So if you look at JBoss, or if you look at any other application server that is provided by IBM or Oracle, if you compare it with that, then the web container is just a subset of that, and it is only a subset of your application server, which can be used for hosting your servlets and JSPs. So the difference between web container and your full-fledged application server is that your application server can host JSP, servlets, and EJBs as well, whereas your web container can host only JSP and servlets. Does that answer your question?
Yeah. Thank you.
Okay. So, if you look at the network diagram of any organization, it can be much more complicated. It could have multiple servers.
Pawan?
Yeah. Yes.
When you say, yeah, I'm looking at the definition. Threads have a lot of benefits over the processes, such as they share common memory area, lightweight, cost of communication between the threads are low. What does it mean there?
Yeah, I'll tell you the exact meaning when we look at multi-threading. But the thread, if you compare it with processes, what happens in processes is that it has a different memory. So if you want to switch from one process to another, right? So still, if you have a single core CPU, which is, say, assume that you can process only one instruction at a time. Okay. So when you have to switch from one process to the other, when one process is idle, you want to switch to another process. So the user gets a feeling that there are multiple processes that are getting executed within your machine on your system. So that switching time that it takes from one process to the other is more because it has a different memory. It has to switch to a different memory area, and it all goes into a stack. You have to pop out information from that stack, and you have to push more information in the stack. So that it takes a lot more time. Whereas threads are much more lightweight. Switching between threads is easy because they share the same memory space as well, the memory area. So I'll explain it to you in more detail when we look at multi-threading. Just understand now that whatever you said is correct. So threads, when you compare it with processes, they are much more lightweight. And
when you say lightweight, you mean to say like they contain, they handle less memory or something, or threads versus processes? Processes, I understand it, but threads is like you spawn a new process. Is that what it is, like, or like something like a Unix processes, right? In Unix you have multiple processes, child process, parent process, and all that.
Yes.
So in case of threads, how does it look like?
Yeah, it's like when I say lightweight, it means that it is when switching. So why would we have multiple processes if we can't execute them parallelly, right? But the problem with executing multiple processes parallelly is the switching time that it takes, because it is not lightweight. It has different. It needs its own memory space. So switching from one process to the other is going to take time. I think let us hold this question till we cover multi-threading, because we're going to look at it in much more detail. So then it will be clear. I have a slide that explains completely about the difference between the processes and threads and why threads are lightweight and all that. Okay. So for now, if we had a separate process for each of these, okay, for each of the servlets, then when it has to quickly switch from one one servlet to the other and sharing information in servlets and all that, it's going to take much more time. The threads, they share a common memory area where they keep all the information, so it's like sharing the same bucket of information, so they're much faster. Switching from one thread to the other is much faster. Okay, so you have control over how many threads you can allow your container to create, and then we will look at these methods when we write a program. Okay. So how do we write? Okay, before we look at the servlet in more detail, let us understand the difference between get and post. Now we saw that you can the client can send an HTTP request, right? Just a sec. Gopi is asking a question. Can we use JSP for session management? Yes, we can. We can use JSP for session management. That is a short answer. We'll look at that when we look into it in more details. Okay, in a later session.
Cool. Thanks. Thank you.
Yep. All right. So. Okay, so let's move on with our servlets. So if you look at this diagram, the HTTP request is what is being sent from the client to the server, right? So the HTTP request, there are at least two methods that you have to understand. One is get and the other one is post. So these are the methods that can be used by the client to post its request. Okay. I'll show you the difference between get and post, but let's look at this table first. In the case of get request, only limited amount of data can be sent because data is sent as part of the header. If you look at, say, Gmail or Google.com, if you go to Google and you type in some search, if you type in a search, so let me go there. Let me go to Google. So over here, if you look at, say you want to type in some search for something, say enterprise Java. Okay, you're typing in enterprise Java, and you get some results on your Google page. What you can see is that the content that you had sent, okay, when you type in Google and you open it up, it's basically a secure connection that gets built. So it redirects to a secure server, which is an HTTPS request. When you type in Enterprise Java, okay, and send that request, before you get that response, you are sending that request. When you're sending that request, you are sending this URL. So what is the URL that it is sending? It is sending google.co and search, and then a question, a query is equal to, so it's a parameter that you are sending, Q is equal to enterprise plus Java, okay, which means that you are sending a query which is like enterprise plus Java. And of course, it is also sending many more parameters, which is not of use for us. It is also sending the source ID and all that, so it sends a lot more parameters. What I wanted to tell you is, when you are sending, this is an example of a GET request. When you're doing a GET request, so even if you go to say,
Pawan?
yeah,
Pawan?
yeah,
Yeah, can you do it again? I was just reading that screen got vanished. Yeah.
yeah. So if you look at, when you're sending
Yeah.
a request, say for enterprise Java.
So what is first thing is search, right? Yeah.
Yeah.
Search.
So yeah. So whenever you're doing a search, say I did a search. So all I did is I typed in enterprise Java here.
Right.
And I clicked on search.
Okay.
And this is the page that it displays. So what was the request that you had sent? It is basically an HTTP request that went in, right? So what was the request that you sent, and what was the URL that you were trying to access? So the URL was https www google.co.in, and then you are trying to search, right? So it says /search, and then it follows it up with a question mark, and then you have a list of parameters like the value key value path. So its q is equal to what? The query is what? Enterprise Java. Okay, and it has some other parameter as well. OQ is also equal to Enterprise Java, and more parameters, AQS, and a lot of other parameters which doesn't make sense to us. But the main parameter that I want to talk about is the query that I had put in over here. That request has gone in as part of the URL itself. Okay, so this is one method of sending your HTTP request, and that is called GET. So usually you use this method when you want to get a particular resource, when you are querying some other server for some information. That is when you use GET request. So a GET request is more like your select statement to the database. You are querying the database, right? So if you are querying, say, Google, here you are using a GET request. Okay. When you are using GET request, whatever parameters, what is the parameter, what is the value that I want to send? It was Enterprise Java, that is sent as part of the URL. In the same way, say Wikipedia. I open up Wikipedia and I am searching Wikipedia for some content. Okay, so I want to know about, say, I want to know about Bill Clinton. Okay, so that request that goes in, it goes in as a GET request. So these are all GET requests. Okay, so let me go back here, and even though you are not able to see it here, I'll show it in Chrome Developer Tools. Okay, to open up Chrome Developer Tools, I have to press F12, the function key F12, and after opening it, I can go to the Network tab. Okay, and now I search for Clinton. So you can see that as I'm typing, there are some requests that are going on. Okay, there are some requests that are already being sent to Wikipedia, and what is actually happening here is, as I'm typing, it has to try. As I'm typing this, Bill Clinton, what is happening is it is giving me some suggestions over here. So where are these auto suggestions coming from? They are coming from somewhere, right? And these are coming from where, as soon as I start typing, it is already sending me the request. Okay, now I select Bill Clinton. As soon as I select Bill Clinton, you can see that it is sent in many more requests. And you can also see, what is the kind of request that went in. So if I go back, okay, if I go back and go to the original page which sent the request, the original request over here was index.php. I open that request. That request URL that sent in was https wikipedia.org index.php, and search is equal to Bill Clinton. So the parameter went as part of the URL. Okay, and that is what is called a GET request. So the method is GET. Okay, and you also get some response. We'll talk more about the status codes in tomorrow's session. But
Pawan, how did you get here? I mean, I missed the steps. How did you get all those details? I mean, like.
Yeah. So if you are using Chrome or even Internet Explorer,
okay.
Chrome is I prefer Chrome because it's more.
I have Chrome. Yeah. Tell me.
So Chrome in Chrome, if you press F12.
F12. Okay.
Yeah, the function key F12. It opens up what is called Chrome Developer Tools.
Okay.
Those are the ones that are used by developers, primarily by front-end developers.
And it will display all these details?
And over here, there are a few tabs. If you look at the Network tab, that has detailed information on all the requests that are going in from your machine to wikipedia.org.
Okay. It is Developer Tools F12, right? F12 and Developer Tools. Okay. And then network. Okay.
S12 opens up developer tools
Okay.
directly. Or you can go to settings and you will find a link to developer tools.
Okay, yeah, I did see the developer tools, but I didn't give much thought all these years. Okay, now it helps. Yeah, thank you.
Yeah.
Go ahead.
So if you look at the network tab, that will give information on what are the HTTP requests and responses that that is being sent from your client machine to the server which is hosted by Wikipedia. So the first request, when I typed in Bill Clinton and I sent in the first request, that request was like request URL is this. And over here you can see that it is being sent in as a parameter. So the search parameter is basically Bill Clinton over here. Okay, and the method, what is the request method that is being sent, that is being used? It is get. Okay, so basically your HTTP request, okay, has two parts. One is the header and the second one is the body. So your request, if you're sending in your search parameters or your parameters through the request header or through the URL, it is called a get request. Okay, if you are sending it as part of the body, which is like the here it is showing the response header. Okay, you also have the request header as well. In the same way, you can have a request body. So in the request body, if you are sending in all the all the parameters, then it is called a post. I'll show you post as well later, but just understand that a get request is sending it as part of the header or as part of the URL, whereas in post you will be sending in the same parameters as part of the body, so it will not be visible through the URL. Okay. So what happened is it sends this request to Wikipedia, the get request. Okay, the status code is 302 found. Usually you get 300 series response, for when you are being redirected. Okay, so as part of the response header, you can see the location to which it is being redirected. Okay, the location to which it is being redirected is this page. So it then, when your browser got this redirect request, which is, say if you got the response which is 300 series response or 302 found, is basically a response that a server sends when it wants to redirect the user to some other page. Okay, so for this request it is sending back a 302. Your browser got back this response. It reads the location in the response header that came back as part of the response. Okay, this location is again opened up in the second request. So the second request after this request, the second request, if you see in the network tab, is to this page, which is Bill Clinton. So https wikipedia.org/wiki/Bill Clinton was the page that it was redirected to. So your browser opens up that page. Again, it is a get request only because there is no nothing else that is being sent as part of the body, and the status code is 200 OK. When you get a 200 OK, it just means that everything is OK. It has got whatever page it has requested. Okay, so here, so it basically sends two get requests. One, it sent a request for searching Bill Clinton, so it doesn't. We send that because we don't know the exact page where we have information on Bill Clinton in Wikipedia. Okay, and that is the get request. But as part of the response, the server says, okay, I can redirect you to the page where I have information on Bill Clinton. So you have status code 302. Based on the status code, the browser understands, okay, you are asking me to go to some other page. And what is that other page? It is available in the response header under location, and it says in Wikipedia, Wiki Bill Clinton. It reads that and then it again sends a get request to that page. So when it sends a request to, say, Bill Clinton page, this is the page that gets open. So basically we have been using get request here, and you can see, you saw that the server can also respond. it responded with a 302 when it wanted the user when it wanted to redirect the user to some other page. It responded with a 200 okay if it was able to send back the page itself. So based on what you are trying to respond with, say you try to access a page which is not available, then you get a 404. You may have faced it so many times. A 404 is the response code that the server sends when it says that you're trying to access a page that I don't have. Okay, so 404 is a response code that the server sends back to the client when it wants to tell that you're trying to access a page that I don't have. So based on what the server intends to respond with, it responds with the status code as well. So it sends a response like 200 okay if everything is okay and it's sending back the response. It sends back 300 series if it wants to redirect the user to some other page. It sends back 400 series if there is a user error. So if he is trying to access a page that is not available. It sends back a 500 series if there is a server error. So you can see there are multiple series of errors here, or status codes that it can respond with. So coming back to your get versus post, before that let me just list it out here. What we saw just now, the basic HTTP response codes that one can respond with. So you have 200 series error, 200 series response code you send back from the server if everything is okay, when it's sending back the page. It sends a 300 series, means it is redirecting. It sends back a 400 series if it's a user error. For example, 404 means page not found. Okay, it sends back a 500 series if it's a server error. If there is some error that has occurred on the server, maybe the database is down or something has happened because of which it could not respond. Okay, for example, database is down or something like that. Okay. So,
and are these numbers standard, Pawan? 200, 300,
yes, these are standard. These are standard. These are part of the HTTP specifications. So W3C is the the World Wide Web Consortium that has defined these standards for the web, right? So it has defined these standards. Okay, so basically a 200 series stand for everything is okay, based on whether it was just a page that was sent back or whether it was a successful update or a successful delete in the backend. Based on all that, it may send a different status code altogether. 300 series is when it wants to redirect to a different page. Okay, so it's asking the browser again to ping some other page. Okay, and the 400 series is for user error committed by the user. Maybe he has typed in the URL wrong. And then the 500 series error is the server error. Say something, the request from the user was okay, but there was some error that happened on the server side. So it is not able to respond back. Okay. So these are the different response codes. So when we also respond from the servlet or the JSP, we also respond back with the appropriate response code. Okay. So now again, coming back to get versus post.
And who, Pawan, go back to the error codes. How are these error codes generated? Any idea? Who generates, like which port? Say suppose there is 300 series. Who is doing this? I mean, is it the server does it, or who generates the code? And
we have to do it as web application developers. A lot part of it, the Servlet API will help you do that. Okay, so even if you don't specify, it will assume certain things, like if you are sending back an appropriate page, it will assume 200 OK. So certain things the the servlet API will handle, but we have to handle it is left to us to send back an appropriate response code that the that our client can understand. But you don't have to directly type in, okay, this is the code that I want to send, whether it is a 300 or a 302 for redirecting. You use an appropriate API within your program. You say you send a redirect to the client. I'll show you how to do that with code, and just by calling that API, it internally sends an appropriate response code. Okay. Does that answer?
Yeah, partly yes, but I want to see like which part of the network is generating the error codes, and how does the transfer happen, that inter-exchange between the inter-generations and the viewer seeing the series and all that stuff.
Yes, these response codes are these are generated by our own applications. If it is the 4.4, then even the web server.
Just a out of track question. Is it like on this kind of socket communications? Is it a part of socket communications?
Yes, these are actually abstractions on top of socket communication. We normally deal with socket communication at that level. When we are writing Java programs, we are assuming a lot of things. We need not know about a lot of things that are happening underneath. It's like if you look at the whole OSI model with all the 7 layers from the application to the physical layer, we have all the different layers. So what we are looking at is just the application layer. We are not even looking at TCP/IP right now. So we are just looking at writing a web application, and then that gets translated to everything up to the physical wire that needs to transmit the bytes that are the zeros and ones that you
have. So where in the OSI layers, 7 layers, where does it fall? This one? Presentation layer?
The topmost, which is the application.
Application layer, okay.
So at the topmost, which is the application layer, at that layer is where we which is interacting using the protocol, which is HTTP.
Right.
Our application layer uses the HTTP protocol, and as part of the HTTP protocol, which means the rules for how to send the request, how to send the response. The request will have certain fields, certain parameters. It has certain methods like get and post. The same way, the response also has a header and a body. You can send some headers back. You can send some body back, which is rendered by the page. And you also send a response code back. So these are defined inside the protocol itself. So these are defined by the protocol. So that is the protocol that we follow. There is a communication protocol that we follow in the internet. So looking at that, let's look at get and post again. Get, we saw that we are sending all the data as part of the header itself or as part of the URL. Okay. Whereas post, you are not sending that as part of the URL. It could be for 2 reasons. Why would you not want to send it as part of the URL? You may want to hide what you are typing in. Say you are typing in the username and password and you are sending it across. Okay. Usually the password field is not displayed, but if you are sending it as part of the URL, then it is visible to others. It is visible to others if it is sent as part of the URL. You cannot send the password as part of the URL. So it always has to be a post. It has to go in as part of the body. If it is inside the body and if it is encrypted inside the body, people will not be able to see that. So that is one. Security is one. Well, the second one is the amount of information that we are sending. If it is a simple search, like I just typed in Bill Clinton and I'm searching, it is fine. But what if you want to send a lot of data as part of the request? What if you want to upload a huge file? You can't you can't just get all the the byte stream out of the big file and put it as part of the URL. There is a limitation to how much amount of data that you can send as part of the URL. So you can send as much amount as you want as part of the body. So you use post when you have to send large amount of data. Okay. and it is more secure because data is not exposed in your URL bar, right? And then, but one advantage of Get is that it can be bookmarked. Say, say this is my favorite page. Okay, Bill Clinton in Wikipedia is my favorite page. You can bookmark this. Okay, or the search. So the search that I've done over here, you can bookmark this, which means that if I need to search for Enterprise Java some other day, I can just take it out of my bookmark and I can just execute that. I can just save it as a link and I can just click on it. But you can't do the same thing if it is a post, because this criteria will not be as part of the URL. Okay, so you cannot bookmark post requests. Okay. The other thing is the GET request, by definition it is idempotent. Idempotent means a second request will be ignored. It does not have any impact. Okay, no matter how many times I query for Enterprise Java, I will get the same result. Whereas a post is used for updating something in the backend. So if by definition, post is used for updating something in the backend, which means that if I have to say update something like if I need to add a new student or update my student information, I want to update some personal information, I move to a new address and I want to update my address using a web application. So I put in my new address and I click on submit. When I click on that submit button, it has to go and update something in the backend, right? So it is done once. It is not idempotent. So for example, if you are crediting, if you are transferring say $100 to some other account, if you hit if it were not idempotent, then if you hit it twice, then instead of $100 you would be actually be sending $200 because that action would have happened twice. Okay, so that is why post is we say post is not idempotent, whereas GET request is idempotent. Okay, now and then GET request is more efficient, whereas post is less efficient because it also has a body and it has to process that body finally on both the client and the server side, and that is why we say GET is more efficient. But use whichever method you use, GET and post, you understand what it is and then use it accordingly. In some cases, it may not matter whether you're using a GET or a post, but if your request has to be more secure, use a post. If you're submitting a form, use a post. And if you have anything like, based on the scenario, you use it accordingly. Okay, you use either GET or post accordingly. If you have to send a large amount of data, use post. If you are hearing some noise in the background,
Muted.
okay, I have muted everybody because I was hearing some noise in the background. Please unmute yourselves if you have to ask something. I can hear that Gopi has posed a question. How do you get the suggestions when you type the search query without any GET or post request? Okay, when I typed in, there was a request that was being sent continuously. There was interaction, but that technology is called AJAX. It's an AJAX request. It is an asynchronous request that we'll be covering in a later session again, because it's a whole new topic altogether. But it's not that you cannot interact from the client to the server without a GET or a post request. But this is an AJAX request. It is a special kind of a request. It is a GET request, but the thing is, it is posted asynchronously, which means that you don't really feel that something is being submitted. Okay, so that technology is called AJAX. You can read more about it, but that will be covered in a later session. Okay, so let's move back to our slides here. So that was the difference between the GET and post methods. Now, how do we write a servlet then? So we have to move on and look into the code, right? So how do we write how do we write our servlets? For that, within the Java Enterprise, within Enterprise Java, within the Java Enterprise Edition, we have something called the Servlet API. Okay, and the Servlet API, the most important class, or the topmost class of that, is the Java X Servlet. Okay, with the Servlet class, which is that the servlet. This is the package. The Java X Servlet and Java X Servlet HTTP. These have the classes that we need for creating our servlets. Java X.Servlet is more of a generic package. Okay, so it has some generic classes which are independent of the protocol that are being used. But for us, since we are dealing only with HTTP protocols and we are writing web applications, we'll be using the Java X Servlet HTTP package, which has classes specific to the HTTP protocol. Now, the Java X Servlet, which is some generic protocols that are being, if you are using some other protocol, like this is the age of Internet of Things, right? We have been hearing about Internet of Things. We have devices. We have, I think, more than 50 billion devices are connected to the Internet today. And not every device that is connected to the Internet is using just HTTP. You may want to configure a device which is streaming some data directly to your application using some other protocol that is used by your big data and IoT kind of applications, by your smart devices, or I should say the smarter devices that we have, the intelligent devices that we have. So not everything is HTTP out there, but what we are dealing with is web applications, so we'll be using only HTTP. Now we also we'll come back to this again, the life cycle of the servlet. But then from a theoretical standpoint, the servlet class that you have written, it gets loaded, okay, and it creates an instance of the servlet. So basically an object of that servlet gets created in heap, and then there is a method called init method that gets that gets executed. That has certain basic initialization that you would want to do for your servlet. So then your servlet is ready for use. Now, how is your servlet used? It is used by calling the service method of the servlet. Okay, by calling the service method of the servlet, your HTTP post or GET or whatever request you have, it calls the service method and then it sends back an appropriate response. When all that, when it finishes, responding back, and when you are shutting down your server, that is when the destroy method is called. I'll come back to this after we look into the code. First, before you write code, you will need Tomcat. You will need the Tomcat container installed. You have detailed information on how to do the setup in this particular link. So I have that link also open. So let me just go through that once. It also has a video. This is a good link for for installing Apache Tomcat in Eclipse IDE. So basically, what you have to do is the first step is to download Apache Tomcat. Please download whatever is the latest, whether it is 8, 8.59, or whichever is the latest. So download the latest Apache Tomcat. Okay, you can download the zip version of that. Okay, so if you have a Windows machine, just download the zip file, extract it. Installation of Tomcat is simple. All you need to do is extract it onto some folder. Okay, once you have extracted, this is how you can see the folder over here. Okay, so then open up your Eclipse environment. You have to go to your servers tab. I will show you in a short while where you can find the servers tab. But you have to click on the servers tab, and then you have to right click on it and add. You have to add that particular server based on the version that you have added. If you have added a version 8 server, whether 8 or 8.5, if it is 8.5, then you have to add Tomcat version 8.5. If it is 8, then just add Tomcat version 8 server. Just select that and click on next. Once you click on next, it takes you to a page where it asks, where have you installed Tomcat? You have to point it to the directory where you have unzipped that folder. So wherever you unzip that folder is the place where the Tomcat, that is the Tomcat installation directory. So you're over here, you're giving the installation directory information. So then it will pick everything from there. So that completes your installation. To run Tomcat, you have to you can change the port at which it is running by changing the configuration. The configuration information and everything, all the documentation is available in the Tomcat Apache Tomcat site and very much detailed. With the default port that it uses, you can change that as well. Then you can control Tomcat directly from Eclipse, the way we were doing it for Oracle. Tomcat, you can even start and stop your Tomcat server, your Tomcat container that we are using for, you can start it or stop it from your servers tab as well. So once you start it, then only will you be able to run your web application. So so the detail, how to do that is available in this YouTube video as well. You can refer to that. You can ask me tomorrow in case you are not able to, install it, or you are facing some issues, or just write to me, and I'll respond to that. So once you have installed, then within Eclipse, here I have already created a program, but let's see how to create one. Okay, so how do I create a project which is a web application? Till now, what you have been using is you go to File and you would create a new Java project, isn't it? But now this time you have to create a new dynamic web project, something called a dynamic web project. So you are actually creating a web project which is a dynamic web project. Okay, once you create that, say next. Okay, when you create a project, the next screen it asks for the project name, right? So you can give it some name. So say just saying hello is the name of my project. Okay, so it's target runtime. I have 8.5, so I'm just using that. I've already configured Apache Tomcat version 8.5. Okay, and then you can leave everything else as the default. Click on next. It just says just gives you some options for you to create your source folder and all that. You don't need that, so just say next. Okay, and it asks you what is the context root is. Just keep it default. You don't have to change anything over here. Okay, and you can select that you want to create a deployment descriptor. It's your option whether you want to create it or not. For now, let's not, but later we'll create a project by also generating the web XML, because you can configure a lot of things using deployment descriptor, which is your web XML file. And let me say finish. So I'm just creating a basic thing without a web XML file. I'm just creating a basic dynamic web project, and I say finish. Okay, this kind of project is associated with the Java EE perspective. Till now I've been using the Java perspective, and I say Java EE perspective. Yes, I say yes, and I say it opens up the Java EE perspective. It doesn't look much different, but it has a few more things like the servers tab over here. So it also has the servers tab, and the way it displays your project is also can be slightly different. Okay, it shows your deployment descriptor, it shows your Java resources, it shows your JavaScript resources as well. It shows the build. It has a yes, Srini.
Yeah, can we run the previous programs also on this EE version, like developer programs?
Yes.
Like
yes, we can.
Okay, so both, so we can EE version can run both the previous old programs as well as the EE programs. Am I right?
Yeah, it's just a different perspective here. The different perspective means what is available over here in the different tabs.
But otherwise,
perspective.
No, I'm talking to codes, Java, public classes, and all that programs. We can run it, the codes.
All that will run. All that will run.
Okay, okay.
Yeah. So if you look at this, it is just changing the perspective. Everything will run the way it is. The perspective is just that the options that you have over here is slightly different. You'll also see a servers tab, okay? And the servers tab is like, you have a Tomcat version 8.5 server that is already loaded here, and you can see that it has something called first over here. There's a project that I have already loaded into that. So if I right click on this server, I have control over that. I can restart the server, I can stop the server, I can publish the server, I can publish some information, and there are so many different options that I have over here. Okay, so we look at the options as we go through, because we will just be going to be looking at servlets for the next 2 or 3 sessions. Okay, so for any web project, the most important folder I would say is the web content folder. That is the folder that is the most important. And if you have to share, say if you want to share your web project with someone else, all you need to do is just share the web content. Okay, just share the web content. Whatever is under the web content is what you need to share. And then it has a meta-inf folder, and the more important one, the web-inf and the libraries. If you have any more libraries that you will want to add, it goes in over here. Okay. So this basically is your basic dynamic web project. Now, since I had already created a dynamic web project here, I will show the other one, which is what I've done is in your you can look at the different Java resources that we have, and I've created a class called hello.java. This basically is a servlet that I have written. So you can create a new Java class over here, which is a servlet, and for now, since I've just created it under, so there is no other difference between the first project and the just saying hello project. I'll just execute the first one, which is say it has under source, I've just created a class. So what I did is to source, I just created a new Java class the way we used to do, and then I created a hello.java class. What is there inside the hello.java class? Okay, there are a few import statements. Okay, after that there is a servlet implementation class that says hello. Okay, what does this do? Okay, so basically this class extends HTTP servlet. HTTP servlet is a class that is available within your JavaX servlet HTTP. I had showed you in a previous slide that this is the package that has the classes that are required for you to write a servlet. So your JavaX servlet HTTP has 3 classes that we are using. One is HTTP servlet. If we extend HTTP servlet, then this class will also become a servlet. So this class will also act like a servlet. So it can also take in HTTP responses and respond using HTTP. So to do that, we also need 2 more classes, which is HTTP servlet request and HTTP servlet response. So these are the 3 classes that we need to write a basic HTTP servlet. So how do we write a basic HTTP servlet? The first one, you create a class called hello, and you basically it extends from HTTP servlet. Now, if it is extending from HTTP servlet, it has certain methods that it can override, isn't it? Yeah, and for that, what it can override is basically the do get and the do post. You override the do get if you want to handle get requests. You override do post if you want to handle post requests. Okay. Since I'm handling both get and post in the same manner, and I don't want different functionality for that, all I'm doing for do post is again calling do get. So For do post, whatever request and response objects I am getting, okay, I am just passing it on back to do get. So the functionality that I have inside do post and do get are the same. Okay, so whether I send a get request or a post request to this application, it is going to stay the same. Now there is a specific annotation that you can use, which is at web servlet. Okay, so this basically is, since this is an HTTP servlet, it is a web servlet, but what is the path that I should go within my server so that I access this servlet? For that, this is the path. So how do I mention the path? I just say at web servlet and the path. So the path is /hello. So if I go to /hello, I'll be able to see the output of this program. Okay, and then how do I implement this do get request? First, I have the request and response object. So first what I'm doing is I'm reading the request. The request, as part of the request, I am expecting a parameter called username. Okay, if I pass a parameter called username, how do I pass a parameter in the get request? Like we saw when we did a Google search or a Wikipedia search for Bill Clinton, then the parameter was passed as key value pair. So in the same way, this request also would have a key value pair with key username. So I'm trying to access that parameter called username, like as request.get parameter. Okay, so request.get parameter of username only accesses the parameter called username. It gets the value of the parameter username. Okay, so that value is stored in the string username over here. Now that I've got the request, all I want to do is, since I'm just showing you a basic example, I'm not processing it too much. All I'm doing is I'm getting the username from the parameter and I'm printing the same thing back to the user as part of response. So how do I send the response? How do I send the response? The response dot set content type. First, I'm setting the content type of the response, which is text/html. This is what I have to do if I'm sending back an HTML response. Okay, so the response dot set content type, I'm setting the content type as like text/html. You can set, this is called the MIME type. Okay, so the type of the response is also called the MIME type. Okay, so this is basically to tell your browser what is the type of the response that you are sending back. So if you're sending back a PDF file, you can say application/PDF. Okay, so there are some standard values that you have to use over here. So for example, if you're sending a PDF file, you say application/PDF. If you're sending an image, then you have an appropriate MIME type for that as well. So if you're sending back an HTML page, is what I'm sending back, I say text/HTML. Okay, now how do I write the response back? So to write the response, I have this response object. I have to get the writer of that response. So I do response.getWriter, which is nothing but a print writer object. Okay, I call it out and then I say out.print. So whatever I print here is sent back as a response. So how do I send the response? I do a response.getWriter. I call it out and then I do out.print. Whatever I print here is sent back as a response. Okay, so I do out.print. What I'm doing is basically printing an HTML page. An HTML page is, if you already know, then it would have an HTML that has a header and a body. So I'm just sending an HTML with just a simple body with say I'm sending, this is header font size 1, header 1, and then I'm also using marquee so that it scrolls. Okay, the whole hello username scrolls and then hello along with username, and same from servlet 1. Okay, and then so this is basically I'm constructing the HTML page here. Okay, so now let's execute this. So how do I run this? To run this, I have to go to the project. Okay, right click on the project and go to run as. This time you're not going to run it as Java application. Instead, you're going to run it on server. You cannot run it as Java application. You have to run it on server. Okay. And I'm hearing some background noise, so let me move. Uh, okay. So, how do I run this application? Okay. So, right click on that application and then run as. This time, don't run it as a Java application. Instead, run on server. Okay. So I say run on server. You have it gives you an option, okay, to choose an existing server or manually define a new server. Of course, you have defined once you have defined Tomcat, you can choose from an existing server. My server is Tomcat version 8.5 at localhost. The state is already started. Otherwise, it will auto start this. Okay. And then I say next. I can see that there are a few projects that can also be added, and these are available for adding. But the one that I've configured now is to configure. All I have to do is move this project from here to here by clicking on this and then say add. Okay, but I already have this project, so if you see, I can move it from this to this. So I can remove this from here if I have added something else. But I'm trying to run the project called first over here, so I just select first, which is under configure, and I say finish. Okay. It is asking whether I need to restart server or continue without restarting. I can restart the server, so let it restart the server. So you can see that in the server console, it is showing you that the let me open the console here. It shows that the console it prints in a few lines over here, and it says that the server startup in 589 milliseconds. So the server has restarted. So I know that the server is restarted. Ensure that the server is restarted, and then it auto launches your application. So what is your application? HTTP. It is in localhost. It is in port 8080. That is where Tomcat is running. Okay. To access that, first it goes into the project that you have defined, which is first. But to access my servlet, if you remember, where is my servlet? To access my servlet, it is under /hello. So if I go to /hello, I'll be able to access my servlet. So I say, after first I say hello, and I enter, and it says hello null from servlet 1. So why is it printing null here? Okay, that is because it is not, I have not sent any parameter as part of my GET request. Okay, so what has happened here is I have when I access localhost 8080, it has reached my Tomcat, which is running. Inside my Tomcat, this is the name of the project, which is first, and inside the project I am accessing a servlet called /hello. Okay, and that /hello is defined by this path, and that /hello, it goes here. And since this is a GET request, any request by default, unless you specify, it is GET request. Okay, if it has to be a POST request, you have to specify it to be a POST request. Now this request by default, it is a GET request. So I go to hello. So this GET request, it comes over here, and then inside my do get, I'm trying to access the parameter username. Since I have not specified any parameters, my string username is the value is null. And then what am I printing? I'm printing as part of the body a heading with header size h1. Okay, and I'm using marquee for scrolling, so that the effect that you are seeing over here, the scrolling effect, is because whatever text that I have over here is surrounded by the marquee tag. Okay, since I use the marquee tag, it is scrolling. Okay, and then I say hello, comma, and I concatenate it with the username. Username is null, so it says hello null from servlet 1. Okay, now instead of that, now if I had to supply a username as parameter, how do I do that? After the URL, I have to put a question mark, and then I have to use the key, which is nothing but the username is equal to, I say my name is Pawan, so I just say Pawan and I say enter. Okay, so what you see is that when I hit enter, this parameter, which is username is equal to Pawan, has been passed to this servlet, and this is a get request. So inside my do get method, I am accessing request.get parameter username. So the value of that username now is Pawan. So the string that it has constructed over here is hello Pawan from servlet 1, and that is the output. Okay, so this is a basic demo of a basic servlet which is accepting a get request over here. Okay, and as part of the response, it is sending back an HTML. Okay. Any doubts here?
Good.
Thanks, Pawan. The only question I had was, this is Gopi. The response, right? You're writing to the response, but you're not passing. I understand the request is getting the request from the URL, but the response object, we're not initializing, but it still takes the browser as a response, right? How does that happen?
Yeah. So a lot of things are handled by the Servlet API. That's why when we were discussing about, this is at the application layer, we don't have to code into so much detail as to which socket is sending back the response, and then to which port it is going to, what is the IP address of the client. All this is being handled internally by the Tomcat container. The Tomcat container records the request, it sends the request, and what I'm doing is I'm just writing the response. So as soon as my doGet method is over, okay, as soon as my doGet method is over, this response is being sent back to the Tomcat container. The Tomcat container, what it does is it sends this HTML page as part of the HTTP response. Okay, so
okay.
And I can even, here I'm just loading it within Eclipse. I can access the same URL from Chrome as well, or from any browser. So I'll copy this onto Chrome. Okay, and then I run this and I click on that, and you'll see the same output over here as well. You can use any browser to access this. So your application, your web application, whether the simplest web application possible, is now hosted on Tomcat. The Tomcat is running. So if I try to access localhost 8080, okay, it has got nothing over there, but you can see that Apache, it says Apache Tomcat 8511. This is the version of Apache Tomcat that is running on this port, and that's why this are now showing a 404, because nothing is available in the root directory. Okay, so instead of accessing the root, I'm going into my first project and then into the path that I've specified over there, along with the parameters. Now if I open up, so let me open up developer tools over here. If I open up and see using my Chrome developer tools, inside the network tab you can see nothing is recorded. Okay, that is because I just opened up the Chrome developer tools. For it to get recorded, I'll have to refresh the page again. So once I refresh the page, I can see that the first request, okay, the first request that goes in is hello. If I see the details of the request over here, let me open this completely. So I can see that the request was to HTTP localhost 8080 first hello username is equal to Pawan. The request method is get. The status code that was responded with is 200. If you see, I have not explicitly specified any response code over here. I have not said 200 OK as response code. But since I am sending back a page, the Tomcat container assumes that it is a 200 OK. Alright. So it assumes that. We will see the other use cases as well. Today we are just seeing a basic application. So it sends back 200 OK. Alright. And it sends back some other response headers also. Those are the standard response headers. Like what is the content type? We have set the content type to text/HTML. This is the one that the browser reads for us to understand that this is an HTML page. To open developers tool, we have to press F12. We have to press F12. So I'll just respond back to that question. So if you click on F12, if you press F12 key, it opens up Chrome Developer Tools inside Chrome. You will also have access to the developer tools from your Chrome or here also. Okay, so if you go to Chrome and more tools, then you can do it opens up developer tools from here as well, or you can just say F12, right? So yeah, so when you
When I am unable to open it by pressing F12.
Are you using Chrome?
Yeah.
Okay.
But I can open it using inspect code, but I am not finding their headers, preview, response, and timing. I am able to finding the above one, but not the below one by inspect code. Right click on.
You have to go to network tab.
I have network tab, but I am not finding the header, preview, and response timing. These things.
Yeah. So these things, if I close this, probably you will be looking at something like this. Okay?
Yeah.
If you click on a particular, request, so these are all the different requests that were sent from your machine to that particular page. Okay. So here, if you click on that, it will give you more details. Okay. If you click on that, it gives you more details on what were the different headers. Okay. It also gives you a preview of the page that is being opened. So this is the page that was sent back as response, HTML body and all that, right? And then your response is also the same. Over here, preview and response is the same. In some cases, it could show slightly differently, okay, in a more user-friendly manner. And then it also shows you the timing that it took. So where did it actually start? So this will be used more for performance tuning. But that is a more advanced thing. And we should at least be able to go to a particular request, and then you'll be able to track what happened to your request. You sent a GET request to this particular URL, and this was the status that you responded with. So this is often used. The Chrome, you have to get used to Chrome Developer Tools. This is often used for all web application development. Tomorrow, even if you are coding with JavaScript, HTML, CSS, or anything, or even JSPs, you will have to be using this to completely understand how the request was sent, what was being sent, did it really send it. You may feel that you had sent some parameter. Now I had sent some parameter part of the URL. You can see that query string parameters over here, username, Pawan. It is showing you all the detailed information about the request and your response. Okay. So, I'll send you a link. Actually, the Google people have done a very beautiful work with Chrome Developer Tools. They also documented it beautifully. I think they also have a site where they explain the internals of JavaScript and web browsers. That's also something that would be good for us to know. But before we, look at all that, it is, start off with writing a simple servlet the way we did it today, and set up your Tomcat, write a basic servlet, and then we'll proceed in tomorrow's session. Any questions you have from today's session?
So Pawan, you will be sharing Tomcat link and from where we have to download. Okay.
Yes, I'll give you the whole instructions. Actually, all the instructions are available in a particular link. I'll share this link, and it also has a video. So it also has a video. So you can go through that video. It has a detailed explanation of how you have to install Eclipse. Okay, so how do we proceed with that? I'll send you the link for the installing Tomcat, the Tomcat container, and I think you should be able to write your first servlet today, and we will proceed on servlets on that tomorrow. Next, what we have to look at is the life cycle of a servlet, and then what are the different options? How does it interact with the business logic layer? And our basic. Once we look at the basic stuff, then we have to look at it from a higher level, which is like how to do session management, how do we ensure that a transaction, what is a transaction, what is the difference between a transaction and a session? So how do you do all that? How do you secure your applications? How does security within your web containers work? So these are the things that we look at in the upcoming sessions. So probably till end of this week we are only going to look at servlets. Okay. So any more questions? Okay, so if there are no more questions, then probably we'll stop here today, and we'll continue with servlets tomorrow. Thanks a lot.